Hey guys, this is Lyndon again for part 2 of the light rays. We're talking about the flat earth, and according to the flat earth theory, they say that the only reason these light rays are not parallel is because the sun is very close to the clouds, alright? And they say the sun's about right here, but that doesn't work. Okay, I explained last video, that doesn't work with the flat earth either, because the flat earth says that the sun is 3,000 times higher than clouds. All right, because we looked at the Wikipedia. It says the sun and moon are 3,000 miles above the ground, and then we showed that clouds are only 1 mile above the ground. So 6,000 feet, 1 mile, basically 1 mile. So according to the flat Earth, the sun is 3,000 times higher than the clouds. So according to the flat Earth, the sun is nowhere near those clouds, so it doesn't work. So that's not a possible explanation for the flat Earth either. So it doesn't matter what you're on. If you're on a flat Earth, you can't say that they're close to the clouds, and if you're on a round Earth, you definitely can't say they're close to the clouds. All right. So either way, they're extremely far away from the clouds. So that doesn't work with a flat Earth or round Earth. So then we have to beg the question: why are these light rays not parallel? Why do they, or I'll say this, why do they seem not to be parallel? So they obviously are in different angles, but we know that perspective can change, distort your views about things. And last time we actually looked at this railroad track, and obviously these two railroad tracks are parallel. These two railroad tracks are parallel, but they don't seem parallel because of perspective, and that's what everyone says happens with these light rays. And some people don't think that that's a plausible explanation. Okay, but today I'm going to show you how it absolutely is, and I did this by doing a 3D model. So here we go. Here's my drawing of a cloud, and here are the light rays. All right. So you would have to say that the sun must be right behind this cloud, all right, because these light rays are going out at different angles. But if we actually take a look at it, they're not. They're all completely straight, and we can see from the sun they're all parallel. And it may not seem like that when you're down with the underview here. They don't seem parallel. That's because of perspective, and just the way perspective works, that's what's going to happen. So here in this video, I just demonstrated that it can be deceiving. See, we have these straight parallel lines, and because of perspective, it tricked you into thinking that they were not parallel. So let's take another view. See, this is just another view. They look like they're not parallel. One's going off this direction, the other's going off the other direction. But because they're getting closer to you, they're coming at you, the light waves are shooting at you, that shows that's the reason why they don't look parallel, because it's perspective. It gets bigger as it comes closer to you. So, and that's what's going on here. So there's actually ways you can prove that the light is actually coming towards you. Here's this original clip. Alright, so I have, let's see here. There we go. So this is this clip, and I add a little bit of contrast so you can see the light waves. There we go. And basically, here we have some light rays coming out of the clouds, and basically they look not parallel. So we have light rays going this way, and we have other light rays going this way. So they don't look parallel. But we can prove that these light waves are actually coming at you and causing that perspective effect by looking about. Well, let me just first tell you something. If you're riding down the road, you're riding down the highway, and then the trees are whizzing by you. But if you look far into the distance, it doesn't look like anything's moving. Like the moon doesn't look like it's moving, but the trees are whizzing past you, and that's because the moon's further away. So things that are further away don't move as fast. Things that are closer whiz by you. So here we can see that these light rays. You can see that the bottom part of the light rays are actually moving very quickly, and the beginning of the light rays are moving very slowly. That shows that the beginning of the light rays are farther away, and the end of the light rays are closer. So the light is shooting at you. So let's go ahead and play this. Let me show you what I mean. Look at it. The bottom of the light rays are moving very quickly, and the top are moving very slowly. So let me go ahead. I trace this out so you can kind of see here. Check this out. All right, so we're going to pay attention to this light ray right here, this one right here. And then as we go forward in time, you're going to see that the bottom, look at that, the bottom is moving much more quickly than the top. So you can see here that the bottom has moved this far, and the top has only moved this far. It shows that the bottom is moving faster. That means it's closer. So those light rays are shooting at you, and that's what causes that perspective effect. Just like here, these light rays are coming at you. Or another example, just like these railroad tracks. These railroad tracks are coming at you, and that's what's causing them to look unparalleled. So we can actually prove that this is what's happening. The light rays are actually coming at you because the bottom part of the light rays actually moves faster when we move like an airplane. And pictures are very deceiving. Like in pictures, you can't tell this is coming at you. It looks like it's just moving to the side. But that's just a picture. But when you actually see it in motion, you can actually tell that these light rays are shooting at you. There's actually more evidence to show that these light rays are shooting at you. I've got several photos. I'm going to show you one of those photos, and that's actually this one right here. This one's it. You can see here the light's coming out of this hole, and actually where it hits the ground is right here. So these light rays are actually coming at you. See, look where that light hits the ground. That proves that light ray is actually coming at you. See, this is that cloud is far away, but then this spot where the light hits the ground is very close. So that shows that it's actually shooting at you. The light's coming at you, and that's what's causing that perspective effect. I've actually done this before. I filmed it, and it doesn't look like it's coming at you unless you see observable evidence like this light splotch. But we know it's coming at you because the flat Earth, the flat Earth says the sun's 3,000 times higher than the clouds, so that doesn't work. According to the flat Earth, the sun is not even next to the clouds because, I mean, airplanes aren't as high as the sun, obviously. According to the flat Earth, the sun is 3,000 miles above the clouds, and according to the round Earth, it's 93 million miles away. So neither of the models have the sun next to the clouds. So you can't say that's a possible explanation. We have to say it's perspective, and there's a numerous amount of evidence to say that it's perspective that's causing this light ray problem. And we can actually look at light rays from pictures. Let me just go ahead and see if I can find this. Right here. See, these are actually light rays right here. Alright, these are called light rays, and they are parallel. It's just when you have this perspective effect that makes them look unparalleled. Let's go ahead and take another look. See, they're completely parallel, just like in this picture right here. They're completely parallel. But when you have a look under, the perspective causes them to look unparalleled. So it's actually proof, and I'm going to show you one last proof, and this is going to blow your mind. It's amazing proof. Take a look at this. I'm going to go past. Well, first off, if you get from the right view, they look about parallel. See, these aren't actually coming at you. They're going straight down, and they look parallel. So that's just one example. But anyway, look at this forest. All right, in this forest, these light rays are not parallel. So a flat earther would say that the sun is right behind these trees. But it's not. It's just because of perspective that thing is. See, if they say if the sun's far away, then all the lines will be parallel. See, but the sun's not just right behind those trees. I mean, you can't. The sun's not behind those trees, yet these lines do not look parallel. So it has to be from perspective. There's many other examples. Check this example out. They're not parallel, but the light is not behind those trees. It's far, far away. And more examples over here. They're not parallel, yet the sun is not above those trees. It's far, far away. And that's the same exact thing happening with the clouds. It's not above those clouds, just like the sun is not above those trees. Yet they're not parallel, and it's just because of perspective. It is because of perspective. And it's hard to show with photos, but if you see light rays in real life, you know it's because it's coming at you. And this is another example right here. They're not parallel, but that sun is not above those trees. It is not barely above. It's way far away. And this one actually shows it very clear that the light source is far away and actually comes and hits the ground right here. And it shows that the light is actually coming at you. And that's what causes that perspective effect. So I think I've shown this point very clearly. I hope you guys, agree with what I'm saying. Actually, just see the point in what I'm trying to make here. I guess that's all I have to say. I'll go ahead and stop talking now.